Welcome everyone. I am Ms. Shraddha Gaonkar from Government College of Arts, Science and Commerce, KPM, Goa. Program Bachelor of Science, that is first years. Subject is Chemistry. Semester 1. Paper code CHC-101. Paper title is Inorganic Chemistry and Organic Chemistry, Section A. Title of the unit is Atomic Structure. Module name is Dual Behavior of Matter and Radiation. Module number is 2. Outline of the module: Dual Behavior of Matter and Radiation, de Broglie's relation, and a problem. Outcome of the module includes: a student will be able to set up a relation between wavelength and mass of the particle. A student will be able to solve problems using de Broglie's relation. If radiation, that is light, is considered to have particle nature, then the phenomena such as photoelectric effect and blackbody radiation can be explained easily, but at the same time it fails to explain interference and diffraction pattern. And if we consider radiation to have wave nature, then the process of interference and diffraction pattern can be explained easily. But now it fails to explain photoelectric effect and blackbody radiation. So, based on these two studies, Einstein in 1905 proposed that light, that is radiation, shows dual behavior. That is, light will behave like wave, will show wave character, and it can also show particle character. In 1924, de Broglie also suggested that matter, which is made up of particles, is showing dual behavior. That is, it shows wave-like character as well as particle character. Overall, we can conclude that radiation and matter have particle nature as well as wave nature. So, in short, we can say that they have dual nature. In Bohr's theory, electron is treated as a particle. But according to de Broglie's theory, electron shows dual character. So, de Broglie derived an expression for wavelength associated with the motion of a particle of mass m moving with velocity v. So, de Broglie's equation for the wave-particle duality of electron can be derived as follows. If photon is assumed to have particle character, then according to Einstein's theory, its energy is given as E equal to mc square, where m is the mass of photon and c is the velocity of light. That's our equation 1. If photon is assumed to have wave character, then according to Planck's quantum theory, its energy is given as E equal to h nu, where h is the Planck's constant and nu is the frequency of the wave. That's our equation number 2. Equating equation number 1 and 2, we have h nu equal to mc square. Now, since nu is equal to c by lambda and replacing nu in the above equation, we get h c by lambda, which is equal to mc square. Cancelling the common terms on the either sides of the equation, that is c, and rearranging the equation, we get lambda equal to h upon mc. Further, replacing c by the velocity v of the particle, we have lambda equal to h upon mv. mv can be replaced by a factor called p, that is momentum of the particle. So now we have lambda equal to h upon p. This equation, that is lambda equal to h upon p, is nothing but our de Broglie's equation. So now let us solve a problem by using the de Broglie's equation. Calculate the momentum of a particle which has de Broglie wavelength of 0.1 nanometer. The solution is as follows. Since the wavelength lambda is given, which is equal to 0.1 nanometer, we need to convert nanometer to meters. So in this conversion, we need to multiply by a factor of 10 raised to minus 9. So 0.1 nanometers become equal to 0.1 into 10 raised to minus 9 meters, which can be further written as 1 into 10 raised to minus 10 meters. According to de Broglie's relation, lambda is equal to h upon p. Lambda is given in the problem and we all know what is the value of Planck's constant. So, by rearranging the equation to find out momentum p, we get momentum p equal to h upon lambda. Now, substituting for the value of h and lambda, we write the equation further as 6.625 into 10 raised to minus 34 kg meter square per second and lambda equal to 1 into 10 raised to minus 10 meter. So, the final answer for momentum becomes equal to 6.625 into 10 raised to minus 24 kg meter per second. Here are my references. This is the first reference and this is the second reference.